In these two examples that you see here, I'm going to show you how to write the equation of a line that is given in point-slope form and translate it into slope-intercept form. So here's the first of the two examples. The point in this equation, if you know the formula y minus y1 equals m and then x minus x1, that's the formula for point-slope form. The point in our equation is going to have opposite signs as what you see in your function, because the subtract sign here is going to mean that we should have a subtract if our point was a positive. So my x coordinate here that's paired next to my x was actually going to be -6, because when you subtract a -6, your function here would be positive. And then if this is supposed to be a subtract of your y value, again, the point is x1 comma y1, you'll notice that this sign is also opposite. So if my point was -2 for the y value, minus a -2 is how this function has a plus. So my point has opposite signs as my equation. Now for the slope of the line, that's the fraction that you see in front of your set of parentheses on the right side, and that fraction is -1/3. So to get my equivalent formula in slope-intercept form, there are two steps. Number one, distribute your slope. And then number two, solve for y. And get that y isolated alone. So it should then end up looking like y equals mx plus b. So I'm going to start by distributing my slope here. And so this would be my step, y plus 2. Now if I distribute my slope, it would be -1/3 x, and then minus, because negative times a positive 6, 1/3 of 6 would be 2. Now to solve for y, all I need to do is move this 2 over to the other side here, and I'm going to do that by subtracting 2. Now my y will be all alone, and it will look like mx plus b here, because my slope is 1/3 x, and then my b is -4. So my y-intercept now I know, because of my slope-intercept form, -1/3 x minus 4, I know that it will cross my y-axis at -4. So this is just the way that you convert. It's two steps: distribute slope and solve for y. So if you feel bold enough, go ahead and try this, this equivalency by distributing slope and solving for y. If you want, pause the video and see if you can get it. Otherwise, just follow along and watch through, and then I'll teach you how to do it at the same time that I'll do it. So here's our formula for point slope form, and I'm going to convert it into y equals mx plus b formula. Now again, the first thing I'm going to do is name my point, and my point is opposite signs as you see in your function. So my x value here is going to be -5, and my y value here is +10. The slope is the number that's right in front of your set of parentheses. Sometimes it's given to you as a fraction, and sometimes it's not. Just write down whatever that number is. And now what I'm going to do is those two steps that I talked about. Distribute my slope and solve for y. So if I start by distributing my slope, I'll have y minus 10 is equal to -3x minus 15. And now if I solve for y, all I need to do is add 10 to this side, and I'll have my y equals mx plus b. So y equals -3x here, and if I simplify this piece, -15 plus 10, I get -5, and that is our slope-intercept form of our equation, which means now I know another additional point on the line besides just -5, 10. I know the point 0, -5 is also a point on my line.